Okay, welcome to the lab for use case realization implementation with principles. Objective is to learn object design with implementation using software engineering basic principles. In our agenda, we have to introduce you to this lab, code and action, code use cases, and then code with debugging. The basic principle that you will realize in this lab are the model view separation, separation of concerns, and the grasp set, which consists of controller, creator, high cohesion, low coupling, pure fabrication, and information expert. And also we will discuss about data transfer object. So basic overview about the application is that we have online shopping application for the database of Northwind from Microsoft. And in our application architecture we have three layers. One is the user interface layer, and another is the model layer with sub-packages of GTO and validations, and then we have a third layer, data access layer. So all the concerns are separated into their respective layers. For example, the UI aspect is separated into UI package or UI layer, and then the model is subdivided into sub-concern of data transfer objects like these ones, and the validation in this part, and also the business logic, the controller and the factory in this package. So let's run this application and you will get the idea about it. Run file. So this is, you click on the implies and you go to implies form, in which the view use case is by default executed and the implies from the database are populated in the table. Not with all the columns, but with specific columns that we want to populate. And then this is the search use case. For searching implies, you provide any query and it will use the like query to match with any column, and if that match with any column, that record will be filtered. And then we will cover the add use case by this, starting from this button, and then we have update, delete, and we can go back. So let's start with the add imply use case. You click on this button. So note that clicking on this button is just an event. It's not a system event, because let me show you the code. So the code for this button is only that we create the object of add imply. We pass this object like the imply UI object to it, and we also inject the object controller. So this is dependency injection for add imply UI class, right? And then we call its method to make it visible and set visible of the current imply UI to false, so it will disappear. So note that we are not hitting the model or the business logic in this code. So that is why it is only an event. It is not a system event. You click on the plus button, so the add imply or new imply form is displayed, and then you can just provide any value, say and the type is let it be admin, and then we have two options to save it or bait save. So let me explain it a bit here. When we click on the bait save, so we do the non-engineered code, and we save this new imply without engineering code, without using any principles and so on and so forth. But when you click on the save button, so the implies is saved with proper engineering principles, and that code will be executed. So first let me execute it by the bait save. So you see implies added successfully. And now if you want to view this in database, so this is our table, Northwind, which you can download from the internet and set it up on your SQL server. And let me execute it again. So you see the Ali Raza record is added with the role of admin. We are not adding the rest of the values. As an exercise in this lab, you will add them by yourself. So in the bait save, we call or we invoke this event, and it call this internal method. And inside this method, first we read the inputs into these variables, then we validate the inputs. I'm doing only for the first name, so we will also add for the last name and the title. And then we add this record to the database. For adding to the database, first we set the connection, then we add the record to the data, imply record to the table, using the prepare statement. That's it. So the first principle was separation, model view separation principle. Now you see that the code of view has the business logic, right? So this part, like adding it to reading the inputs, it is of course a UI part, but then validating it and then adding it to the database, it should be in the model. So we have not put this code into the model layer. That is why we are violating the model view separation principle, which says that neither you control the model from the UI, nor you will control the UI from the model. These are the two basic principles of that principle. So now we use the best approach or the engineering approach to realize how the principles we are utilizing them by calling this method after clicking the save button. So let me explain it with the debugging way. So when I click save button, so now you see the variables are initialized. For example, this obj imply. Now I'm using the data transfer object to avoid passing values by parameters. So I'm encapsulating the values into the implies data transfer object, setting up them in this object, and then we provide this value to the first principle was used as controller. So the controller is it was already injected in this UI class from the implies UI, right? So this is actually your operation. In operation context, you should have written this method as an operation in your operation context, and the return type is response, right? So this will give us an object in which let me also explain the response object. It is a pure fabricated object to handle the response in a better way, right? So in the response object we have a list of messages, right? The message list means that we could have warning, information, errors, etc. So for that purpose I have declared a list of messages, and message another is also a pure fabricated object in which we have the type and the description or the message. So the type is also like it can be warning or something like that. So now you think that we are following the high cohesion, that everything is focused and its type, and the related behavior is implemented in that class. So we are following the high cohesion. So the message type is an enumerations to avoid the type of mistake while using these type of message types, like information, warning in this. So let me go back, and now in the response class you see that I could add this is just the array list object, and I could add the messages to it, right? And when I add those messages, so then I can check for the hash errors. In the hash errors I will iterate the message list, and if any message has a type of error or exceptions, then I will say that okay, there are message errors, otherwise it does not have any error. And if I want to get the error messages, so I will iterate again the list. So this is a mutable object string, and the performance is better than the string, so we can concatenate all the messages with the next line into the string builder and then return it in this method. And the last method is that to check that response is successful, and which is checked by the calling the hash error method that we discussed above. So this is a pure fabricated object to handle the response or to give the response in a meaningful way. So now we use the for step N2 I will use the F7 key. So we came to the add imply method. So this is your operation, or this is your found message that you will design in the communication diagram. So the first thing that we do is using the creator principle, ssFactory.get instance or get a response instance. So this will give us the object, and the creator principle says that you should create objects at one place instead of using the new keyword at multiple places, right? So that we call the constructor from one point. So let me also explain this. It is a simple method, and we just return the response. So we created the response object, and now we will pass this by reference to the second part was to validate the inputs, right? So we use the common validator, which is a pure fabricated method pure fabricated object, and we use its method to validate imply. So now we can go into imply, and you see that I'm checking the first name now here in this pure fabricated class common validator, and I'm checking if the first name is null or the length is less than 3. Then what we are doing, we are associating the message, the new object message, to the response object. And note that I'm violating the creator principle here as well, so this is for you to fix it, okay, later on. And also you have to add the rest of the validation for the last name in the title. So now using if add, I am stepping over, and now assume that validation is done. Now I'm checking the response if it was successful, so I will not go into detail because I explained it before. So now I am going to the data access layer object, the Dale Manager class, right? And I am calling its method save imply, and passing this response object as my reference. If there is any errors, those will be accumulated into this object, and I am passing the imply object as a DTO. So let's go into that method F7, and the save imply, the first step is to connect with the database. So here I am also using the OBJ connection, which is the class of the SQL connection, right? Let me also explain it. SQL connection is created, and it is implementing the iConnection method, in which we have the get connection declaration. So, and that get connection is then implemented here, right? We have overridden it here. So the reason is that if you want to use another principal, polymorphism, and you want to get the connection for the Oracle or MySQL servers, so you will have to override those methods with their respective connection string. So we have the driver manager, and how this driver manager is coming from, we have actually included the driver for the MS SQL Server JDBC, Microsoft SQL Server Java database connectivity, and the version I'm using is 10.2.1. and note that it is now compatible with my version of the NetBeans. So if you are using older version with newer NetBeans, or NetBeans is the latest one, the older one, but the version for the driver is the latest one, so you will face the connection problems, right? So I'm using this with the Apache NetBeans 13, so you should be careful about this. So now this driver manager definition is actually inside this library, okay, which I have added. How you add it? You just download it from the internet and then click on this and add jar files, and then you locate it where you have extracted it, and then select the version that you need to use. So in my case, I have created a dependency folder in my project, and I pasted that driver here, and I'm using it inside the project. So if you are going to give this project to someone else, so the driver will copy it and go along with the project source code, right? So now the next step is that on driver manager, I'm calling it static method get connection, and I am providing these connection strings like this. And how these values are coming, they were already set up from the Dale manager when I was creating its object, right? Over here, OBJ connection and its constructor, new SQL connection. So I am passing my machine name. These 4 details are required when you are going to connect with any database in the world. So you provide the server name, you provide the database name, the user ID, and the password. So let's step over, and now the connection is established, and now you can see that this connection object is established. So if there is any problem, you will it will throw the exception, and that will be caught here, and you will have to investigate. So after the connection is established, now the next step is to save the implies using the adder. So in my case, for adding new records, I have created another class of data access layer adder. You see this one, records adder, and I have records mapper, and I have records modifier. So these are different concerns I have divided. This is not necessary that you should follow exactly the same concerns. You can separate it like the implies management concern, and then you can have other concerns, managers, database management concerns, and you can create respective classes for them. In my case, I have just used this approach, right? So it is not strict, but the main point is that you should use high cohesion so that whatever the class is doing, the concern should be visible to the user or developer. So over here I am calling on the header the save imply method. So let's step into it by using F7, and inside the method now I have received the dependency of the database connection and also the response object and the implies the data which I have to add. So I'm based on the connection, I'm preparing a statement, prepare statement, and this is the insert into implies, and the values and the question mark are actually to avoid the SQL injection attacks. Through SQL injection attacks, user can hack your code. Actually, I am not going into the detail, but these question mark are then replaced in the next line, right? P dot set string on the first question mark, this value will be replaced. On the second question mark, this value, and so on and so forth. And then I'm executing the prepare statement, execute update method. So update is used for inserting or updating records. For reading, you just say that execute, simply execute or execute only, execute query. So in this case, whatever number of records are inserted, the count will be returned and stored into this. So I'm checking if the count is greater than 0, then again add a successful message, imply added successfully, and it is a type, its type is information. So the new object is again created without following up the creator principle. So here you should have like something like SMS factory dot get instance of message, and passing these two parameters, so the constructor will be called inside that method, and then you will get that object, and now you are associating it with the message list and the response object. So both note that here the array list of the message list, it is actually the API class. So we are not in the, when you are drawing the communication diagram, we are not expressing the API classes in our design. So we will draw the association between the response object and the message object. Okay, so you do not have to specify the API classes details in your design. So just, and now we will be finishing with this method. So let me step over using F8. So now you see that one record is inserted and the message is added. Now we can go back. So now the add imply method of the OSS controller. So now the UI is informed with a proper pure fabricated object. So now in the response you can see that what is our outcome. In the message list we have one message of type information, and this is the message. And on the UI side, I'm also utilizing the pure fabrication method level, that I'm saying that okay, handle the response, and I'm passing the response object and in which label the result should be shown to the user. So I'm also passing its reference. Okay. In your case, from other forms, this label could be something else, but the object will remain same, right? So now you can step into that method, and now I'm checking that okay, if there is no error in the, if there is any error in the code, so you say that okay, in the labels I will show that with the red color, and if there is no error, I'm again skipping some code for you here. You will have to add the rest of the condition, like if there is no error, then you should also display the information message. So you will add the code here as well, right? Currently I don't have written that code, so you will not see any output on the screen. So I have just continued the code, and you see there are no messages shown here. And now we can go back to the implies and just refresh the list, and you see the record is actually added. You can also see the record is actually added by just leave it here, and you just execute it, and you see the new record is added here. So now you have noticed that which principles we have covered. We have covered the data transfer object, we have covered the separation of concern, we have covered the model view separation principles, and all the principles of the GRASP. Almost the information expert I have not explained it, but at the moment we didn't had any information already on the object based on which we are going to allocate it any responsibility. So actually 6 principles were used in these examples. And also note that this code is available online on the GitHub under my username and the learn repository. And then when you go to the learn, you will have to go to the object-oriented software engineering folder, and then code, and then NetBeans projects, and then the name is school management system. It is actually online, or whatever name you call it. In the beginning I just called this method. So you come into this folder, and this is the whole code, right? So you can check it out and run the code and improve the code, the engineering code, the missing parts and the missing principles which where I have violated them. So that's your lab exercises. I will list the task for you, and then you will have to complete them.